Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to complete the conic sections. Yesterday, we did or last session. I don't know if it's going to be yesterday or this morning, because I started to cram the videos so that I can finish before, uh, give you ample time before the Regents to review before you take it. So we did the circle and the ellipse, and today we are going to do the parabola and the hyperbola. I will start with the parabola, solve a couple of problems on that, and then do the hyperbola. Hopefully, we can finish in one session. Okay, so what is the parabola? We already learned about that when we solved quadratic equations and we drew quadratic functions. So generally speaking, I can write the parabola as y equals ax squared plus bx plus c, okay? Or I can write it as x equals ay squared plus by plus c. We learn about that because that's a function. We didn't learn about that because that's a relation. It fails the vertical uh, line test, but the idea is the same. I know that if A is positive, this thing opens up. If it's negative, it opens down. This one, if A is positive, it opens to the right. If A is negative, it opens to the left. We knew that for a parabola, I have here the vertex, right? And the coordinate that is linear, not square, not quadratic. The linear is the axis of symmetry. So here the axis of symmetry is vertical. Here the axis of symmetry is horizontal. Again, this generally speaking, it would be written as y minus k equals some constant a times x minus h quantity squared. So I will, if I'm given it like that, I will complete the square. So I get that after factoring the a out, and then the rest will move to the other side. Okay? So the most important thing we have to say here is for a parabola to be fully defined, I need two more things. I need a point that we call the focus, as you know. This is the focus. And the focus is always inside the curvature. So if this is opening down, it would be below the vertex. If it's opening up, it's above the vertex. If it's opening to the right, it's to the right of the vertex. If it opens to the left, it's to the left of the vertex. Also, there is another line here, imaginary line that we don't see. That is equidistant from the vertex. So the vertex is exactly midway between the focus and this point down here. And we call this line the directrix. And it follows the y, meaning this equation is y equals something. If it's opening to the right or to the left, then the directrix would be x equals something. It's not only that distance equals that distance, but any point on the parabola is equidistant, meaning the same distance from the focus as from the directrix. Of course, this is not drawn to scale, so it looks like this line is longer. It is longer in as I drew it, but if we draw this to exactly, precisely, these two distances would be exactly the same. So this point moving along the parabola, always the distance from any point moving along the parabola to the focus is the same as the distance between this point and the directrix. So this becomes, we call this C, okay? Some textbook calls it P. It's really the nomenclature P or C, P or C. When I write the equation in this form, this number A right here equals 1 over 4c, or 1 over 4p if your textbook says p. Doesn't matter. So p is the distance between the vertex and the focus, or between the vertex and the directrix. And again, if this number is positive, it's above. If it's negative, it's below. I'm talking about the focus. And if it's opening to the right, it's to the right. If it's of the vertex, if it opens to the left, it's to the left of the vertex. So we are going to take a couple of examples, solve them, and then I already circled this this problem because the others are either circles, ellipses, or a hyperbola, which we'll do later. So we will do that later. And then I have another 5 graphs that we are going to plot. Okay, so this equation, you see here, the one that is linear is an axis of symmetry. So this one, and because y is positive, y equals something. So we'll see, in order to write it, we will say y equals, and then we move everything to the right. So we will add 2x squared to both sides. The left will, and then we add 20x to the left side and to the right side. And we will add 46 to both sides. So we will get that. Okay? Now the x squared coefficient is positive. The leading coefficient is positive. So it's opening up like that. But now we need to find where the coordinates of the vertex are. I know that x is -10. Do you see that? We'll see. We'll see. No. Negative b over twice a would be -5, right? That's how we learned negative b over twice a. We learned that from the quadratic formula. But anyway, and then we have to add c or p. When we calculate it, we'll add it to the coordinates of the vertex to get the coordinates of the focus, and then we will subtract it to get the equation of the directrix. That's it, and we are done. However, here we need to complete the squares. And to complete the square, I usually prefer to factor out the 2, even though we'll end up with, we may end up with fractions, but it's easy. So I'm going to factor the 2 just for the x square and the x. And then I'm going to close the parentheses and write plus 46. Notice I didn't factor the 46, so it stays 46, not 23, because I didn't place it inside the parentheses. Now I need to complete the square. So I divide 10 by 2, it becomes 5. I square it, I get 25. And someone say, okay, so I added 25, I have to subtract 25. Did you really add 25? Yeah, some of you got it. Notice I factored the 2 out. So every time you factor the 2, be careful to how much you added. I added 50, not 25. So I have to subtract 50. Okay? On the right-hand side, I just need to have something that looks like that. So I get equals 2 times x plus 5 square minus 4. So I'm going to add 4 to both sides, and I get y plus 4. So here I have 3 things. I know 3 things. I know the vertex. So the vertex would be -5 for the x. Notice the x is the square, not this. And -4. That's the vertex. Also, I need to find P or C. So I'm going to say A, which is 2, equals 1 over 4P. I'll do the cross, so I get AP equals 1 or P equals 1/8, which is 0.125. So my graph would look something like that. This point is -5, 5 and negative 4. For the y, which is the negative 4, I'm going to add this so it becomes negative 5 and negative 3.875. And then I'm going to subtract that, and I will get a point here that is negative 5. I don't care about the negative 5, but negative 4.125. And that is the directrix. It's hard to, of course, to graph this on with 0.125 on this sheet. So I just didn't do it. But quickly, I can see that the vertex is here. This is 1. You have to divide it into 8 parts to find the directrix. So it's really so hard to show it here. But you could use a calculator to find it, by the way, or to plot it, to graph it. You can take few points just to draw this carefully. So I see that when x is 0, y is 46. You see, it's very out of the page. So that's why it wasn't even appropriate to use this graph to plot it. But this is the general shape of it. We got all what we need, the most important parts. So the vertex, the focus, as well as the directrix. Let's take another one. There is another one on this page. Ellipse, ellipse, circle, this one, and hyperbola. You will do the math here. This one also has y as the axis of symmetry, so it's opening up or down. In fact, it's opening down this time. Why? Because when I move these to the other side, they become negative x squared plus 12x minus 36. Okay? I will complete the square. So I'm going to factor out the negative because usually the negative is outside. Be careful. This would become x squared minus 12x minus 36. Okay? Then to complete the square, I divide the negative 12 by 2. I get negative 6. Square it, I get positive 36. I really didn't add 36. I subtracted 36. Again, this is very common mistake. Always you have to look if there is anything outside that will be distributed. So this is, I subtracted 36, so I have to add 36 so I don't get anything wrong. These would cancel, and I will get y equals negative x minus 6 squared. So my parabola is opening down. My vertex is 6 and 0. A is negative 1. That's basically 1 over 4c. So c equals negative 1/4, meaning I'm going to go down a quarter. That would be 6 and negative 1/4. And the directrix would be a quarter above the 0. So this is y equals a quarter. I don't like that both were having the y as the axis of symmetry because I wanted one to be on the x so that I add and subtract from the x, not from the y. So anyway, but I found everything I need. It opens down. Its vertex is 6 and 0. Its focus 6 and negative 1/4. And in fact, you can always check, meaning you can pick any point here. So for example, you substitute what if x is 6, right? You get 6 and 0. Of course, we know that. But what if x is 0? You get 0, meaning x 0 minus x is minus 6 is negative 6, square is 36, times negative 1 is negative 36. So you have a point here that is 0 and negative 36. Above it, exactly above it, will be a point who is the origin, 0 and 0. So this length is 36. Uh, okay, so what about this length? Oh, I'm sorry, this is 0 and a quarter. So the distance is really 36 and a quarter. How about this distance? Along the x, it's 6. Along the y, it's 35.75, right? This is like 35 and 3 quarters. Am I doing this correct? What is this, the square root of 36 plus 35.75 square? Yeah, 36 and a quarter like this. Did you see that? So I just picked a random point to check to see if my math is correct. Is the distance to the focus the same as the distance to the directrix? And I got it right. Okay, so next we are going to do the hyperbola. The hyperbola, as I said, and I will explain it through an example right away. I'm not going to waste your time, but I'm going to explain on problem 4. Problem 4 says 4x squared minus 25y squared plus 50y minus 125 equals 0. I see that the x squared and the y squared are there, but their coefficients are opposite. One is positive, one is negative. A positive is the x. So this hyperbola is opening sideways. If it was the other way around, it would be opening up or down. And down, not or. Okay? So you look at the positive coefficient, and that's the direction where the hyperbola is opening. That's the first thing you do. If you find the vertices, then the midpoint will have two axes of symmetry, and this point would be the center. We'll see how we find those. And then we are going to find the foci, the two foci, and you can see that the distance from the center line to the focus, which is C, is larger than the distance between the center line and the vertex. And the eccentricity is C over A, and since C is always gonna be larger than A, so this is greater than 1. That's quickly what we are going to say. So this one, the y's are not written, there is a y component, meaning I have to complete a square. So I'm going to say 4x squared minus 25, and then I'm going to open a parentheses. I'm going to say y squared. There's a 50, but I factor out negative 25, so this is negative 2y minus 125 equals 0. Okay? I need to add something here to make it a perfect square. That thing is definitely a 1, because that would make it y minus 1 quantity square. Did I really add 1? I subtracted 25. So I have to add 25. So this becomes 4x squared minus 25y minus 1 quantity square minus 100, so equals 100. We know that for ellipses and hyperbolas, I want the right-hand side to be 1. So I'm going to divide by 100. And I get x squared over 25 minus y minus 1 squared over 4 equals 1. Ah, that's why they... I don't care which one is larger, like I did in the ellipse. In the ellipse, the larger one tells me if it's opening horizontally or vertically. Here, no. It's always going to open in the direction of the positive number, because you can think of that as x squared over 25, and this is plus y minus 1 squared over negative 4, and the 25 is larger. So another way to think of it. So now a here, this is a squared, so a is 5. B here is 2. And in this case only, c squared equals a squared plus b squared. You notice in the ellipse, it was a squared minus, and again, because of the negative sign. So here we say this is 25, which is the sum of these two. 25 plus 4 equals 29. So c is square root of 29. Okay. Now, this point midway between the vertices, so I have a center. This center is 0 and 1. Bear with me. Notice that if a squared is 25, then a is plus or minus 5. So one of the vertices is 5 and 1, and the other vertex is negative 5 and 1. C is root 29. So this point is square root of 29 and 1, and this point is negative square root of 29 and 1. Okay? Then I want to draw the hyperbolas. We have two asymptotes. In order to find them, since we drew that distance as a and this distance as a, I'm going to draw a rectangle in such a way it's not drawn to scale at all, because that would be exactly in the middle. That distance is 2b, because this is a, and this is distance is 2a. Okay? Now, of course, this would be exactly the center. It's not drawn to scale, as I said, but it would be the center of this rectangle. Let's say it's this point. Then these two diagonals would be asymptotes to the hyperbola. I know it's horrible. I'm gonna probably try to plot it again using the graphing paper, because that would be more accurate. Okay. So we said this is the center. This basically is the vertex. So it's going to look something like that. And we said and this would be the hyperbola. Let's do it here. It's this one, right? So we found the center to be 0 and 1. That's the center. One of the vertices is at 5 and 1, and the other at negative 5 and 1. We can locate it. I mean, square root of 29 is what, 5.4? 5.4 would be 29.16, right? Yeah. So roughly 5.4. This is one of the foci, and that's the other one. B is 2. So I'm going to draw 2 above and 2 below. And this is 5 to the right and 5 to the left. That's the A. Y again? Oops. This is like that. Yeah. Why? Because now these are two asymptotes. And you can see, again, some people try to memorize. You don't need to memorize anything. This line has a slope B over A. And if it were the other way around, it would be A over B or negative B over A. So you can find the slope very easily if you know that you constructed this thing. And then when I plot it, I will try to make that an asymptote, and that's an asymptote. This is an asymptote. And this is another asymptote. And here you go. We found everything. We found A, B, C. Yeah, you see how easy it is? As easy as A, B, C, not 1, 2, 3. We found the foci. We found, we plotted the two. Uh, suppose you wanted to plot that on your calculator, right? Uh, well, this is X, so you can say y minus 1 square over 4 equals 1 plus x square over 25. So y minus 1 square is 4 times 1 plus x square over 25. And y equals, when I take the square root, I will get 1 plus or minus 4 times 1 plus x square over 25. So I can plot that, two graphs. So if I go to y, I can write 1 plus 4 times 1 plus x square over 25. And the second one is 1 minus 4 times 1 plus x square over 25. Did I do it correctly? No, I did not. Because I did the y. No, I did the y, not the x. Oh my God, it's x. So it should be x square equals 25 times y minus 1 square over 4 minus 1, right? This is terrible. Oh, that I didn't even take the square root. I didn't take the square root. Oh my God. Why did I do that? There's no reason. Insert. Oh no, it's not gonna work. Square root. No, clear. Let's see if I can do it. Plus the square root of 4 times 1 plus, not minus, plus x squared over 25 and 1 minus the square root of 4 times 1 plus x squared over 25. I have to delete those. I have here some other stuff at the end. Oh, no, I did. Um, I don't know if we get it right. No, it's still drawing it up, opening up. Maybe. Oh my God, I was doing this one. No, we were solving this one, but it doesn't matter. I plotted it here, but it was that one. Um, okay. Where did I go? I'm going to say this equals this minus one, first of all, because I'm going to move this here. So this is -1, and this is -1. No, I think I messed it up. I think I messed it up anyway. Sorry, guys. Huh. Oh no. And then it plotted, yeah, I corrected it. There was a -1, not a +1, so you get the same result. Sorry, guys, I was in a hurry and I did it incorrectly. And then you could plot the two lines, the lines with passing through the origin, not through the origin, through 0 and 1, with a slope of 2/5 and -2/5. It's really hard. It's really not hard, I meant. Okay, let's do the last one. Number This one. It's still opening right and left. I don't know why they do it both the same thing. So I have 64x squared, and I'm going to add 192x to it and leave a blank to complete the square, and then say -36. Well, in fact, I could have, doesn't matter. So we'll do it on 2 steps. But I factored out the minus. So this would be -36y equals 441. I'm going to move it to the other side. I'm going to factor out the 64, and that would be x squared plus 3x. I will divide by 2 to get a 3/2, and square I get 9/4 minus 36. Oh my God. Times y squared minus y. I divide 1 by 2, I get 1/2, square it, I get a quarter, equals 441. Now, how much did I add? I added 64 divided by 4 is 16 times 9 is 144. So I added 144. And here I subtracted 9. Do you see that? I subtracted 9. -36 times a quarter is -9. So I have to subtract 9 from both sides. Did I do this correctly? Okay, so 64 times x plus 3/2 square minus 36 times y minus 1/2 square equals 594. That doesn't make sense. Oh no, it makes sense. So I'm going to divide by 594. So if you divide if you divide 64 or the other way around, so we know the denominator, 594 by 64, you get, oh, I thought we should get 9. No, they couldn't give us, oh, this is minus 9. So 441 plus 144 minus 9 is 576, which is 24 squared. Yeah, now it makes sense. So I'm going to divide by 576 by 576. So this becomes x plus 3 halves square over 576 over 64, which is 9, minus y minus 1/2 square. And when I divide that by that, I get what, 18? No, 16. 16, yes. So hey, here A is 3 and B is 4. It's again opening to the right and left. The center line or the center of the parabola is negative, hyperbola is negative 3/2 and 1/2. I add 3 to negative 1/2, so I get 1 and 1/2, which is 3/2 and 1/2. And I subtract 3, so I get negative 9/2 and 1/2. These are the vertices. A is 3 and B is 4, so C is 5, right? C square equals A square plus B square equals 9 plus 16 equals 25, so C equals 5. If you want, we didn't do that last time. The eccentricity is C over A, which is 1.666. You wanted me to say 1.67, but I'm not. And here the eccentricity is the square root of 29 over 5. Again, both of them are greater than 1. So because the C is 5, I add 5. So I get 3.5 or 7/2 and 1/2. And I subtract 5. So I get negative 13/2 and 1/2. These are the two foci. Okay, I'm going to construct a rectangle whose width is 6 and height is 8. So I will do, for example, this is like 8. Has to be higher than the width. So let's say it's here. Just quickly, I don't want to waste your time. And these would be the asymptotes, and they would be more open than the previous one because this is higher than that. So now the slopes would be B over A, like 4/3 and negative 4/3. And here is my vertex. It's going to be open, like something like that. And again, passes through this and asymptote. And this would be the hyperbola. So really, it's not hard. It's tedious, I would say. And you have to be, again, if you are plotting it on a graphing paper, make sure it's a large one, not like a horrible one like this. Here again, we are confusing this with that. I'm sorry, I plotted this here. We said negative 3/2 and 1/2. This is the center. And then you are going to calculate like 3 units to the right and 3 units to the left to get the the vertices, and then you are going to plot. It's not easy on this paper. It's very small. But again, I hope you got the idea that it's really pretty straightforward. You have to identify some values A, B, C, and sometimes P if it's a parabola to find where the vertex as well as the focus is. And then I think the rest is history. When you solve like two or three of those, you plot them, you get the gist of it. And most of the time in the regions, they will give you an equation and they won't ask you to graph those. They will ask questions about like the focus or the vertex or the directrix um, or stuff like that. You know, it's opening to the right or up, stuff like that. And again, I'm posting some back exams for Algebra 2 that you can consult before the exam. So now we are still having like three more chapters. So we have we have probability and statistics. We have one for trig, like we introduce the trig functions, and then one for graphing the trig functions and transforming them. How to look at the standard graph, and then how do we shift it or reflect it or enlarge or shrink or stretch it. Okay, so that's it for today. I hope you learned it. You learned the material. If you have any questions, please don't hesitate to let me know. I'll try to get back to you as soon as I can. Otherwise, I hope to see you tomorrow or soon. Have a great day.